as we're working with math, a lot of times we're not going to be given the equations. We often give you the equations to get you started and things like that, but afterwards, the goal of math is to be able to model real-world, realistic situations. So being able to take English language and figuring out ways to make it into an equation that we can then use to model the situation is very important. So we'll just take a brief look at this. There's so many different scenarios, cases, different words and situations, and we'll take a look at them as we approach them. But just for a little bit of practice, here's some key words to think about. Difference means to subtract, so minus, sign. Decreased is another word you can see there. Less, those all mean the same thing, to bring something down by subtraction. Sum, added, the plus sign, increased, more. Those all relate to our addition situations. Product, multiply, the multiplication sign, times, doubled, tripled, things like that. Those all are situations where we are multiplying. In the case of doubled, tripled, doubled, you're multiplying by 2. Tripled, multiplying by 3. When you see the word quotient, we're dividing, division sign. That's about all I could think of off the top of my head. There's probably some others that are out there that we may encounter as we go. So here's a couple examples to practice. Write an algebraic expression or equation for each. An expression does not have an equal sign. An equation has an equal sign. A, the sum of 3 and a number. Sum means we're looking at addition. And of 3 and a number, what number? Well, we don't know, so we're going to make it a variable. I like to use X. You could use N, W, P, Q. You can use a smiley face if you want. So we want to sum these two values. So that's going to be 3 plus X. Or X plus 3. Perfectly fine to write it that way as well. In the next case, we have the product of 4 and a number decreased by 6. So we're doing the product of 4 and a number decreased by 6. This is important to note. There's no comma here separating this, so a number decreased by 6 is one big piece. It's not the product of 4 and a number, comma decreased by 6. There's no pause. So this here has a number, we'll say n in this case, decreased by 6 minus 6, and then the product would be times. So we're going to have to multiply this. So a number decreased by 6 could be n minus 6, and then the product would mean we'd multiply that by 4. So there we have a number decreased by 6 and the product with 4. In the last one, 2/3 the square of a number is 8. So 2/3, 2 over 3, square means we're going to do to the power of 2. Of a number, let's use a smiley face. It doesn't matter what we use for our variables, as long as they're just something to represent a number. You could use a letter, but we're going to use a smiley face for fun. Is would mean equals 8. So if we square a number, so we got our happy face squared, 2/3 of that. So we're going to multiply that by 2 over 3, and that's going to equal 8. For those of you that find that confusing, you could write 2 over 3 x squared equals 8. It's the same thing. Again, this is the variable is just a placeholder for some number. Got 2 more examples here, working with expressions and some word problems. First one, there are 1,024 bytes in a kilobyte. Write an expression that describes the number of bytes in a computer chip with n kilobytes. So 1 kilobyte is equal to 1,024 bytes, and we want the number of bytes in a chip with n kilobytes. So we want an expression, so we're going to have no equal sign in this case. So we just have 1,024 times n. There's 1,024 bytes per kilobyte. So we have n kilobytes. We just multiply those together, and that would get us our value. In the last one, we want to write an expression for a 36 meter squared garden that has a length twice as long as its width. So 36 meters squared, that means we're talking about area. So the area of a garden that has a length twice as long as its width. So the area equals length times width would be our normal formula here. We're assuming a rectangle. The area is 36. The length is twice as long as its width. So the length is twice as long as width. That's length times 2, or width times 2. So 2 widths times the width. There's the length, 2 times as long as the width. And then our width is just width. And so we have 36 equals 2w squared. That would get us our equation here. And so this would probably should be changed. Sorry, that shouldn't be expression. That should be equation. That's my bad. But again, we're taking our values, substituting things in here as needed, and then writing that expression out. So we're translating real-world situations into algebraic expressions, which now this disconnects it from the real-world stuff, and we can do the pure math to solve the problems.